Welcome to World Decoder. Today, we explore the incredible $2.2 billion marvel, the legendary B-2 stealth bomber. This magnificent aircraft represents the absolute pinnacle of modern aviation engineering, combining unprecedented stealth capabilities with devastating strategic global strike power. The journey of creating this ghost of the sky begins with the smallest yet absolutely crucial advanced composite material components. Engineers start in the highly classified composite manufacturing zone, preparing advanced carbon fibers that form the fundamental structure of the aircraft. These specialized materials are meticulously layered to create a framework that is incredibly lightweight, while possessing strength far surpassing traditional steel. Every single sheet of carbon fiber is inspected under intense lighting to ensure there are absolutely no microscopic flaws or hidden defects. The composite layers are then placed into massive industrial autoclaves, where intense heat and pressure fuse them into indestructible structural panels. This rigorous baking process guarantees that the aircraft frame can withstand the immense aerodynamic stresses encountered during high-altitude supersonic missions. Once the foundational structure is solidified, the focus shifts to the very feature that makes the bomber legendary: its stealth capabilities. Workers carefully apply a highly classified radar-absorbent material, known as RAM, over the entire exterior surface of the stealth bomber. This specialized coating is designed to absorb and dissipate electromagnetic waves, preventing them from bouncing back to enemy radar tracking stations. The application process requires extreme precision, as even the slightest unevenness in the coating could compromise the invisibility of the aircraft. Combined with its unique smooth shape, lacking sharp angles, this stealth layer makes the massive bomber virtually invisible to modern defenses. The aircraft resembles a smooth, dark manta ray gliding silently through the ocean, an elegant but deadly shape in the sky. After the stealth skin is perfectly prepared, the manufacturing process moves into the highly demanding phase of massive fuselage structural assembly. This stage represents a monumental challenge in precision mechanical engineering, where gigantic structural components must be joined with millimeter-perfect accuracy. Skilled technicians utilize advanced laser positioning systems to align the massive body parts, ensuring every single contact point matches up perfectly. The alignment must be absolutely flawless, because even a microscopic gap could reflect radar waves and destroy the stealth profile entirely. Automated robotic arms assist the human workers, holding the heavy composite panels perfectly steady, while specialized fasteners are carefully driven in. Every fastener is coated with radar-absorbing materials and smoothed down to ensure the surface remains completely flush and aerodynamically perfect. The meticulous attention to detail during this assembly phase is what separates this aircraft from any other plane in aviation history. Next comes the breathtaking integration of the massive wings, spanning over 52 meters from tip to tip across the hangar. The bomber utilizes a revolutionary flying wing design, completely eliminating the traditional tail section to further reduce its overall radar signature. Attaching these enormous wings requires absolute perfect balance and immense structural support to maintain the strict aerodynamic properties of the bomber. Giant overhead cranes gently lower the wing sections into place, while engineers carefully guide the massive structures into their final positions. The connection points between the wings and the main fuselage are reinforced with specialized titanium brackets to ensure maximum structural integrity. Once the exterior shell is fully assembled, the focus shifts inward to install the complex mechanical heart and electronic brain systems. Two highly powerful advanced turbofan engines are carefully hoisted and installed deep inside the central body of the stealth bomber aircraft. Placing the engines deep within the fuselage is a brilliant strategic design choice, meant to completely hide the massive heat signatures. The exhaust system is uniquely designed to mix hot engine air with cold outside air, cooling it before it exits the aircraft. This thermal management system ensures that the bomber remains completely invisible to advanced infrared tracking sensors used by enemy air defenses. Simultaneously, technicians begin the incredibly complex task of wiring the vast avionics network and the sophisticated digital flight control computer systems. Because the flying wing design is inherently aerodynamically unstable, human pilots alone cannot keep the aircraft flying smoothly through the air. Therefore, highly sensitive flight computers act as the true brain, continuously making thousands of microscopic control surface adjustments every single second. Miles of specialized wiring are carefully routed throughout the fuselage, connecting the central computers to various sensors and hydraulic flight actuators. Every single wire is shielded against electromagnetic interference, ensuring that a nuclear blast cannot disable the critical flight systems during combat. The cockpit is then meticulously assembled, providing the two-person crew with state-of-the-art digital displays and ergonomic seating. Despite the massive size of the aircraft, the cockpit is relatively compact, designed for maximum efficiency during long-duration global missions. Engineers install the complex life support systems, allowing the crew to operate comfortably at extreme altitudes for more than 40 hours. Below the aircraft, the heavy-duty landing gear is installed, designed to support the massive weight of a fully loaded bomber. The landing gear doors are also fitted with radar-absorbing edges, ensuring that no stealth capabilities are compromised when they close. With the physical construction nearing completion, the aircraft enters a rigorous phase of extreme pressure testing and internal system performance evaluations. The entire cabin is pressurized to simulate high-altitude conditions, ensuring there are absolutely no dangerous air leaks in the fuselage. The complex fuel systems are thoroughly tested with special fluids to verify that the massive internal tanks can operate without leaking. Every hydraulic line, electrical circuit, and mechanical actuator is tested repeatedly to guarantee flawless performance under the most extreme combat conditions. Software engineers run extensive simulations on the flight computers, verifying that the digital control system perfectly handles all aerodynamic structural instabilities. The radar-absorbent coating undergoes a final meticulous inspection using specialized scanners to detect any microscopic flaws in the stealth armor. If even a tiny scratch is found on the surface, technicians carefully reapply the specialized coating and smooth it out perfectly. The bomb bay doors are tested, opening and closing with rapid precision to ensure payloads can be deployed swiftly and silently. Inside these massive bays, the rotary launchers are installed, capable of carrying a devastating payload of precision-guided conventional or nuclear weapons. The sheer destructive capability housed within this elegant, stealthy frame makes the bomber a truly terrifying instrument of modern strategic warfare. After months of incredibly precise manufacturing and exhaustive testing, all system indicators finally show green, signaling the aircraft is fully ready. The massive hangar doors slowly open, allowing natural sunlight to reflect off the smooth, dark surface of the completed stealth bomber. A powerful tug vehicle carefully pulls the magnificent aircraft out of the assembly facility, marking its very first appearance outdoors today. Ground crews swarm around the aircraft, performing their final visual inspections before the highly anticipated maiden test flight begins this morning. The two test pilots, dressed in specialized high-altitude flight suits, confidently climb the boarding ladder and enter the advanced cockpit. They begin the complex engine startup sequence, bringing the two deeply buried turbofan engines to life with a low, powerful rumble. As the engines spool up, the flight computers instantly take control, stabilizing the control surfaces and preparing the bomber for takeoff. The aircraft slowly taxis down the runway, its sleek, bat-like silhouette presenting a stark contrast against the bright blue sky. With a deafening roar, the engines are pushed to maximum thrust, propelling the massive flying wing rapidly down the long runway. The nose gently lifts, and the magnificent aircraft gracefully takes to the air, defying gravity with its incredibly unique aerodynamic design. This maiden flight is the ultimate test, verifying the flawless operation of every single component meticulously assembled over the past months. The test pilots execute a series of complex aerial maneuvers, pushing the aircraft to its limits to ensure complete structural integrity. The sophisticated flight computers perform exactly as designed, seamlessly translating the pilot inputs into smooth, stable movements through the turbulent air. Ground control monitors telemetry data in real time, confirming that the stealth systems and engine temperatures remain perfectly within safe parameters. The aircraft climbs to its maximum operational altitude, demonstrating its ability to cruise efficiently while remaining completely invisible to enemy radar. Mid-air refueling tests are conducted, proving the bomber can extend its range to strike any target anywhere on the entire globe. The successful test flight validates the billions of dollars and countless hours of engineering brilliance invested in this revolutionary aviation project. Upon returning to the base, the bomber executes a flawless landing, touching down smoothly before deploying its drag chutes for deceleration. The ground crew erupts into cheers, celebrating the successful birth of another magnificent ghost of the sky joining the strategic fleet. The aircraft is then towed to a specialized climate-controlled hangar, where it will be maintained between its critical global missions. Maintaining the stealth coating requires constant vigilance, as exposure to harsh weather can degrade the highly sensitive radar-absorbing surface materials. Specialized technicians work around the clock, using advanced diagnostic tools to ensure the bomber remains in a constant state of readiness. The magnificent aircraft stands as a testament to human ingenuity, pushing the boundaries of what is physically possible in aerospace engineering. It represents a perfect synthesis of advanced material science, precision manufacturing, and cutting-edge computer technology working together in absolute harmony. Even decades after its initial introduction, the stealth bomber remains an unparalleled asset in maintaining global security and strategic military deterrence. The secrets of its construction remain heavily guarded, ensuring that its technological superiority cannot be easily replicated by any rival nations. Every single stealth bomber ever built carries a unique legacy, representing the absolute pinnacle of 20th and 21st century achievements. As technology continues to evolve, the lessons learned from building this bomber will undoubtedly inspire the next generation of stealth aircraft. The incredible journey from raw carbon fiber to a $2 billion flying marvel is a story of relentless human perseverance. Thank you for joining us on this fascinating exploration of the magnificent stealth bomber manufacturing process and its maiden-flight testing. We hope you enjoyed this deep dive. Please subscribe to World Decoder for more incredible engineering stories. See you next time!